So in this lecture, I am going to talk about the scattering of electromagnetic wave from a free electron, and this is known as Thomson scattering. So let us discuss the diagram, that how diagrammatically things looks like. So electromagnetic wave, this is the electric field component, and along this direction it is magnetic field component. It's like this, and it's propagating along this direction. And here it's a free electron, and this electromagnetic wave, when interacts with this, gets scattered in this direction. So in the Cartesian coordinate system, this can be represented in this manner. Say it is the incident radiation coming in xy plane, and its amplitude is represented by E naught vector. And say this is the scattered radiation, and it is scattered along the xz plane. As we, for the sake of simplicity, we will assume that. So incident and the scattered radiation will make an angle theta with each other, and this scattered radiation means this is known as scattering angle. Scattered radiation and this z axis will make an angle phi, and this with the x-axis will make an angle psi, as we have shown here. So for this, I cut a paper in three-dimensional form and try to show it. So let us have a look at that. So see, this is the diagram which will help us. So here, this is x-axis and this is y-axis. Along this direction, say this is z-axis. So it is the incoming wave E naught, means this is the incoming wave, and it is made to interact with the particle which is sitting here. Now it is scattered along xz plane. Now it is making an angle theta. This angle, whole angle, is known as theta, and this x and this E will be making an angle psi. This angle psi, right? So let me take another color. Yeah, this angle is psi. It is from this to this. And here it is phi. Phi is from this to this, and this angle x-axis with the x-axis and the scattered, it is the 90 minus phi. So this diagram will help us in later on. So let us go back to our derivation. And now in this diagram, what I have shown, when it interacts with the charged particle, it sets into oscillation about its position where it is located in this direction. And as it is a periodic in nature, so sometimes it gets increased and then decreasing. So first, sometimes it moves upward and then downwards, means it's a oscillatory type behavior. So particles show a oscillatory behavior, and because of this nature, its dipole moment will also changing. So this motion leads to the changing dipole moment. This oscillatory behavior of electron leads to changing dipole moment. So we will talk about it later on when we will do the derivations. So now let us start with the equation of motion for such a particle. So the equation of motion will be so let me describe this in words. So since the wave is periodic in time, so will be the motion of particle. Motion of the particle. This sets charged particle in acceleration, and hence it will radiate, because accelerating charged particle will radiate, so hence it will radiate. That is, energy is absorbed from the incident wave by particle and then re-emitted into space. Such a process is called electromagnetic radiation by charged particle. Scattering of electromagnetic radiation by a charged particle, right? So this is with it how we will define this phenomena in terms of words. So let us discuss this mathematically. Since we know that the magnetic field is negligible in comparison to electric field E, so therefore this equation of motion will become this, because this term can be neglected. Why it is neglected? So let us have a look at that why we are neglecting this term. It's a very interesting question, and it can be asked so many times. So since we know that this c is the velocity of light, and it is represented as mu naught and the epsilon naught under the root, where this epsilon naught is the permittivity of free space, and this mu naught is the permeability of free space, and its value is nearly equal to it is 8.85 into 10 raised to power minus 12 Coulomb square Newton per meter square, and its value will be 4 pi into 10 raised to power minus 7 Newton per ampere square. In terms of epsilon naught and the mu naught, we can express impedance or impedance of free space, and this is nothing but it is simply the magnitude of electric field through the magnitude of magnetic field, and its value is 376.73013 ohm, or nearly equal to 377. And we can also express these in terms of mu naught and the epsilon naught. So it is mu naught C, or it is mu naught over epsilon naught under the root, or sometimes it is known as. So from here we are concluding that electric field component is nearly 377 times the magnetic field component. That's why this component can be ignored. So that's why we are expressing our expression in this form. So now let us try to solve this differential equation. Since this equation is a plane wave, this incoming wave is a plane wave. So if it is a plane wave, then this can be represented as this E is equal to E naught exponential minus iota kz minus omega t, if incoming wave is propagating along z-axis, right? Now, substituting this in this equation, this equation will become so this equation can be written in this form. From here, the acceleration is simply E by m E naught exponential minus iota kz minus omega t. So if I will integrate it, then its integral will become dx over dt. Integral will become dx over dt. It is equal to E by m E naught exponential minus iota kz minus omega t 1 over iota omega t. Here I have used the formula that integral of e raised to power ax plus b is simply 1 over a e raised to power ax plus b. So I have used this formula here. Using this formula, I will get this term. Now again, I will take its integral. And if I will take its integral again, then it will become x is equal to E by m E naught, this 1 over iota omega t can be written here, and its integral will be exponential minus iota kz minus omega t, and then again 1 over iota omega t will be here, right? So this after simplification will become minus E over m omega square E naught exponential minus iota kz minus omega t. Now let us take its real part. and considering z is equal to 0, and when I will take z is equal to 0, then the actual position of the electron can be written as it is equal to minus e over m omega square e naught cos of omega t, because z will become 0 and it will become e raised to per iota omega t. Let me do little mathematics here. When I put this is equal to, I will try to solve this part, so it will become exponential iota omega t, because I have taken z is equal to 0, this term will become 0 and minus minus will become plus. It is cos of omega t plus iota sine of omega t, and this is the real part, so I am taking simply the real part of it, so that's why I am writing it in this manner. Now let me write down the charge density in terms of delta function. Charge density in terms of delta function, or I can say that Dirac delta function. So rho actual is equal to E delta x minus x actual. Here I have taken the definition of charge density in terms of Dirac delta function, as where alpha is 1 to n. It is q alpha, means q is the charge, delta x minus x alpha. This is the equation number 1.18 from the book by S.T. Puri on classical electrodynamics. So I have taken this equation, use this equation, so that's why I am getting this one. So now this will become E delta x. Now if I substitute its value, because its value will be negative, as I saw in the earlier lecture, right? So it is minus e over m omega square e naught cos omega t. So using this value, what I am getting, it is minus of minus e over m omega square e naught cos of omega t. So now the dipole, since the charge is under the effect of oscillating electric field, charge is under the effect of oscillating electric field, so this tends to oscillating dipole, and this tends to oscillating electric dipole, as I stated in the beginning. So dipole moment is given as P, it is equal to d cube x rho So this is the definition of dipole moment in terms of charge density. And if I substitute the value of charge density here, then it will become let me call it as capital X. So therefore, this will become minus E. It can be taken outside. It is d cube x into x delta x minus capital X. So it is a standard integral, and its value will be E of x, and the value of x will be this one. So therefore, it is E minus E over m omega square E naught cos of omega t. And so therefore, actual dipole moment is equal to minus E square over m omega square E naught cos of omega t. Here I have taken the simple dipole moment as P. So it is, or you can say that the amplitude of dipole moment means maximum value m omega square E naught. And here I have used the formula, simple formula of delta function, that f of x delta x minus a is f of a. This formula I have used here, right? So now this is the dipole moment. Now average power radiated can be expressed in terms of a dipole moment. So therefore, the average power radiated due to oscillating electric dipole per unit solid angle is given by dp over d omega average value of dipole moment, its square sine square theta and 4 pi c cube. Here I have used the equation 8.94 by SP Puri, which this book I have followed. Now let us define the dipole moment, means the actual definition of dipole moment. So this dipole moment is nothing but Ex, or P double dot means the derivative. If I take its derivative, then it is Ex double dot, or simply Ea, where A is the acceleration. But this acceleration is force upon mass, and force is nothing but E into electric field. So that's why it can be written in this form. So therefore, P double dot is equal to Ex double dot, or I can call it as EEET over M. So therefore, it is E square by MET. So this is a way that how this dipole moment can be written as. Now I have to use the find out the average value of dipole moment. So for that, what I will do, that means I have to find out its square. That means E square by M its whole square. So it is E4 m square E naught cos omega t. I will take its square, and E naught is a constant, so it can be taken outside. So I have to find out its value, right? So now I want to find out the average value of this cos square omega t. Sorry, square should be there because it is its square, and it is E naught cos omega t, so its square will be E naught square cos square omega t. So now to find out its value, means its average value, so it is a integral from 0 to t cos square omega t dt and divided by 0 to t into dt. So its value simply comes out to be 1 by 2. Value simply comes out to be this one. So therefore this will become E raised to power 4 2 m square E naught square. So this is its value. So therefore, substituting this value to find out the value of dp over d omega, it will become E4 over 2m square E naught square, and here it is sine square theta over 4 pi c cube. And let me rearrange it, this part. This is equal to 1 by 2 e raised to power 4 over m square c4. I multiplied it by c with this and this, so it will become c raised to power 4, and it is E naught square, and here it is sine square theta, and c is multiplied by with it, and it is 4 pi. But as I know that this 2 pi nu is equal to omega, or 2 pi c over lambda is equal to omega. So 2 pi by lambda is equal to kc is equal to omega. Kc is equal to omega. So that means k raised to power 4 c raised to power 4 is equal to omega raised to power 4. Also I know that this p is equal to e square m omega square E naught, and omega square is simply, or omega is kc, so that means this p is equal to e square over m k square c square E naught. So therefore p square can be written as e raised to power 4 over m square k4 c4 E naught square. Or what I can say that this k raised to power 4 and p square is equal to e raised to power 4 m square c4 E naught square. So that means this value is nothing what is equal to k4 p square. So therefore dp over d omega is equal to, it is c over 2 into 4, this is 8 pi k4 p square sine square theta. So this is this one, right? Now I have to express this sine theta in terms of phi and the psi, because I want to express sine theta in terms of psi and phi. So if I remember the diagram, then in that particular diagram, let me recall. This is E naught. E naught, it is X cap, it is Y, sorry, it is Z cap, and it is Y cap, and here it is making an angle, this, and it is the R cap, and here this angle is phi, and this whole of the angle is theta, right? As I know that E, if I take these two unit vectors, then it is cos of theta, because it is the angle between E naught and the R. R is the scatter direction. So if I consider this, what I want to incorporate this psi and the phi. So if I express this as cos of theta is equal to, let me multiply here by 1, and this 1 is nothing but x, right? X dot x is again 1. This is this one and this one. If I express this in this way, then that means the angle between this E naught and x is psi. So I call it as the dot product of cos of psi and x and r. This is x and this is r. So this angle is 90 minus phi. So it is cos of 90 minus phi, and these are basically unit vectors. So I can express it as cos of phi and sine of phi. So therefore this cos theta can be expressed as cos psi and sine phi, and cos square theta is equal to cos square psi and sine square phi, and applying this operation here on both sides, and this is nothing but this is sine square theta is equal to 1 minus cos square psi and sine square phi. Now we have to find out the average emitted radiation. Emitted radiation over per unit solid angle, and is defined as mathematically this is equal to C over 8 pi k4 p square and sine square theta and d psi. It is integral from 0 to pi. Here we are taking average over that means taking average of sine square theta over polarization angle. Over polarization angle psi, right? So this is a way that how we take the average, because the rest of the terms are constant. and it can be expressed as C over 8 pi. We have substituted the value of K4P square, and its value is E4 over M square C4 E naught square 1 minus 1 by 2 sine square, let me write down C over 8 pi. It is K4P square. It is 1 over 2 pi, and d psi, it is 1 minus cos square psi, and sine square phi, it is psi. And now I have taken the integral from 0 to 2 pi, right? And this integral will become C over 8 pi, and we have substituted its value. And when I substitute its value, it is e raised to power 4 over m square c4 e naught square, and its integral will become 1 minus 1 by 2 sine square phi. So therefore dp over d omega is equal to e raised to power 4 over 8 pi m square c3 e naught square 1 minus 1 by 2 sine square phi. Now let us define the differential scattering cross section. Differential scattering cross section per unit solid angle, it is d sigma over d omega. It is power scattered per unit solid angle and divided by power incident per unit area. And power incident per unit area, or it can be defined in terms of incident energy flux. Incident energy flux and which is the time average of Poynting vector for a plane wave, and this is nothing, this is simply equal to C over 8 pi E naught mod square. So this is the value of this one. Now, and this is dp over d omega, its average value, right? So therefore d sigma over d omega is equal to dp over d omega divided by c e naught square over 8 pi. Let me substitute their values. It is 1 over 8 pi e raised to power 4 over m square c cube e naught square. It is 1 minus 1 by 2 sine square phi whole divided by C E naught square over 8 pi, and this after simplification will become E square over MC square whole square, and this C will become C raised to power 4, and here outside 1 by 2, and E naught square will cancel out with this. It is 1 by 2 sine square phi. Now total cross section for Thomson scattering becomes it will become sigma, its integral, and it is E square over MC square raised to power 2, and it is 1 minus 1 by 2 sine square phi, its integral, and this will become simply 8 pi over 3 E square MC square raised to power 2. So therefore sigma means total cross section will become 8 pi by 3 E square over MC square raised to power 2, and this comes out to be 0.665 into 10 raised to power minus 24 centimeter square, and this is for the per electron. Right, and the unit of length is called, because it is the unit of length, so unit of length E square over MC square, it is 2.82 into 10 raised to power minus 13 centimeter, is called classical electron radius. And this result is valid provided the wavelength of incident photon is large compared with the Compton wavelength, that is H over MC of the particle, and extent of its charge distribution. So with this, this derivation will be completed. So thanks for watching this video. In the next lecture, I will talk about scattering from a bound charge.